Okay, so today we're looking at lesson 3, solving exponential equations numerically. It's probably one of my favorite lessons. I think it's pretty cool how you can solve these. You just have to be pretty good with your algebra skills to do these, okay? So your learning goal is I can solve equations where the missing information is in the exponent by getting a common base. And I'll show exactly what that means. So what you're going to do is follow these rules. So first you're going to isolate the power. Then you're going to express both sides with the same base, and then you're going to equate the exponents, okay? So what we're going to do for this lesson is follow those rules and go through 7 examples, and then you should be okay with your homework, okay? So to start, how are we going to solve for x? Okay, that's what we're being asked to do to solve for equations, okay? So how do we solve for an x when it's in the exponent? Okay, you can't type it in your calculator. It won't help you. Okay, so what you're going to do is first step would be to isolate the power. Well, the power is isolated. You have a base with an exponent, so it is already isolated. So step 1 for this example is done. Now, we're going to express both sides with the same base. Okay, so we have a base of 3 here. It would be like pretty hard to get base of 3 to 81. So let's go backwards and put 81 as a base of 3. So let's take the bigger number and put it as a base of something smaller. Okay, so all you're going to do is rewrite 3 to the exponent 2x there. And then you're thinking to yourself, 3 to the exponent what is 81? So it is 3 to the 4, or you can plug it around in your calculator if you don't know that. Okay. Now, your next step is just equate the exponent. So because you have the same base, there's a rule that says then your exponents are equal to each other. You can forget the base, your exponents are equal to each other. Okay, pretty cool. So you can just ignore the base, set your exponents equal to each other, and then you're going to solve for x. How do I get x by itself? Well, it's multiplied by 2, so we're going to divide each side by 2, so then x is equal to 2. Okay, if you want to check because you don't believe me, you could go 3 to the 2 all to the 2 is equal to 81. Well, 3 to the 4 is 81. 81 is equal to 81. Ka-ching. Therefore, left side is equal to right side. X is equal to 2. Okay, you don't have to do that check there. I'm just showing you that I'm not making this stuff up. Okay, so let's try this next one. We can't do our step 1 of isolating the power because our power is already isolated by itself. Okay, then our second step is we're going to want to express both sides with the same base. So again, take the thing that's kind of by itself and doesn't have the exponent, so 1 over 25. Let's take that and change it to a base of, let's take that and change it to a base of 5. So what is 125 as a base of 5? It would be 3, okay? But your easier way to do this is going to be write this as a negative exponent. So 1 over 5 to the 3 is the same thing as 5 to the negative exponent negative 3. You have the same bases, so we can just isolate our exponent. So 2x minus 1 is equal to negative 3. Set them equal to each other, and now we're going to solve for x. To get rid of negative 1, we're going to add it to this side. Get our 2 by itself, we're going to divide that 2 out. So it's going to be negative 1. So if you were to do this, 2 times negative 1 is negative 2, minus 1 is negative 3. So 5 to the negative 3 is 1 over 25, which is equal to your right-hand side. Okay, so pretty cool trick to doing these, and you're going to get good at them doing your homework. Okay, so this example, we do not have our power isolated because we have this positive 5. So let's get rid of that. We're going to take 86, subtract 5. Okay, so get rid of positive 5. You're going to subtract 5. So you should get 81. Now figure out what 81 is as a base of 3. So it should be 3 to the 4. Okay, so then your bases are the same. Set your exponents equal to each other, and you don't have to solve for x because x is already by itself. So you have x is equal to 4 there. Okay, so same thing every time, just different examples that we're going to go through. So there's 3 of our 7 examples. Okay, Let's look at this one. So 4 to the 2x plus 3 is 64. So can we get 4 or 64 as a base of 4? Yep, 4 to the 3. So you keep the left-hand side. Bases are the same, so we can ignore them and set our exponents equal to each other. Solve for x, so plus 3, bring it to the other side and subtract 3. Okay, so here it would be 2 times 0, which is 0 plus 3, so 4 to the 3 is equal to 64, which is true. Okay, so that's why you get 0 for that one. That's fine, you can still have that as that answer. Okay, for this example, remember that you have to isolate that power, so we have a 2 multiplied by it, so we're going to divide that 2 out right away. So that cancels that out, so 5x to the negative 4 is equal to 0.04. Okay, and then it might help you if you're able to actually write this as 1 over 25, okay, as that decimal. I would never give you hard decimals that are hard to put into a fraction, okay? So it'd be 1 over 25 is equal to 5x to the negative 4. You're going to write this as a base of 5, but then remember it's easier to write it with that negative sign, just like in that other example. Not negative sign, negative exponent. Okay, set those equal to each other because you have the same base of 5. Add the 4 to the other side. So x is equal to 2. Okay, so just be careful, that's a little trick here. So figure out the decimal as a fraction. Okay, so if you had like 0.75, put it as like 3 over 4 or whatever it is, but they'll generally be nice and easy ones for you, okay? Last two examples, 9 to the exponent 3x plus 1 equals 27 to the x. This time we have an x on this side too. That's fine, and we're going to still follow the same rules. There's just one little extra thing that we do, okay? So can we put 27 as a base of 9? Well, 9 to the exponent 1 is 9. 9 to the exponent 2 is 81, so it's already higher. Nope, so this time we actually have to put both down to the exponent 3. Okay, so 9 as an exponent 3, or sorry, as a base 3 is 2. Then you have to keep your exponent that already exists in brackets. Okay, 27 as a base 3 is 3 to the 3. Put that x there. Okay, then you're going to go 2 times 3x and 2 times 1 using distributive property. Same on this side, 3 times x is 3x. You have the same bases. So you can get rid of those bases to solve for the exponents. This time, let's bring the 3x onto the other side, so you're just going to get 6x minus 3x, and bring the 2 over to this side, so you're going to get negative 2. Then you're going to get 3x is equal to negative 2, divide by 3. So x is equal to negative 2/3. Okay. Hopefully that makes sense and helps you. These ones I'm going pretty fast through algebra, okay, at the end, just because I hope that you know how to isolate using BEDMAS for a variable, okay? This example, 2 to the 4x equals the 5th root of 16. Again, we don't like seeing this like this, so let's write it as 16 to the 1/5, okay? You can write 16 as a base of 2, so 2 to the 4, all times at 1/5. 2 to the 4x is equal to 2 to the 4/5. Okay, you have the base of 2 now, so you're going to have 4x is equal to 4 over 5. How do you get rid of like a fraction? So let's cross multiply. So you're going to get 5 times 4x is equal to 4. Technically that would be over 1. So you're going to get 20x is equal to 4. Divide by 20, divide by 20. So x is equal to 1 over 5 with that fraction reduced. Okay, so hopefully that helps you. Again, these get a little bit harder and just some little small tricks thrown in there, but in your homework, there is lots of examples. First ones are just like getting a common base, kind of simple. More ones, 4, 5, 8, 9 get more difficult. And then 3, 6, 9, you're going to use guess and check because I haven't showed you a method yet to solve these ones. Okay, so good luck. Let me know if you have any questions.